Alright, so this video is going to explain how to use simple interest and compound interest. And the first thing I want to mention is you have these formulas, and the main words I want y'all to get is that these formulas are on your formula chart. Now, on the formula chart that I made, we have this extra information here. But typically, this is stuff that you're going to have to remember to write in. So when I say simple interest, you're thinking here. And when I say compound interest, you're thinking here. Now, as far as what those letters mean, that's what I have these notes here for. So, here are the main parts that you're looking at. So, P means principal, but I typically don't use that word. I'll have you start with starting money. So, how much money are you starting with? R is rate, which I want you to think as por ciento. This is a place to watch out for. A lot of mistakes happen here. Just the easiest way is to divide by 100. And then T, time, is always in years. So on the off chance that they say something like for 36 months, know that you wouldn't put 36 in place of years, you would put 3. 36 months is the same as 3 years. And then finally, these last two pieces. I want to be very careful here. The simple interest formula will naturally give you the answer of interest. How much money your money makes you. While the compound interest will give you the total. It's a total amount of money that you repay, including the interest. Now, what I want to focus on right now is how to use the simple interest formula. Now, my idea here is, does time affect how much you pay? So if you take 6 years, 8 years, or 10 years, does it change how much you have to pay? And hopefully that's something you guys know the answer to, but if not, we can prove it using the simple interest formula. So because of the word simple, I'll use the simple interest formula, and I'll figure out PR and T so that I can use the formula. So what's my starting money? 4,000. What's my rate? Be careful. I said to do por ciento, and some people have issues with that. So when I say por ciento, this is all I literally mean. What's 5 divided by 100? Some people can do this in their head, and that's fine. I don't recommend it though, because if you make a mistake, it'll probably be there. And then finally, for how much T time? Well, you're going to do it for 6, 8, and 10 years. So I'll use all 3. Now, what I want to see every time you work this out is the setup. Now, aside because it's useful, sometimes your answer is just how do you set it up? Now, there's going to be 2 ways to do this. Here's the first method. You can simply just type it in as you see it. So P, R, and T. And if I ask you what's the interest for 6 years, it would simply be 1,200. So in this first example, I equals 1,200. Now, here's a second method to use that I'm going to have you guys use more. It's going to help with the more complicated ones that we see as well. So go to solver, and I'm sure you guys have noticed the green layer of keys in the background. Let me make this a little bit bigger. I want you to type in the formula I equals PRT. So notice that I'm hitting the alpha key every time so I can get the letters instead. Now when you have it set up like this, it's perfect. It's basically set up for you to easily substitute, which I have that information. Okay, so what is my P? Let me make this. All right, so what is my P? So make sure you always keep in mind where your blinker's at. I move down, and my P in this case is 4,000. My R is 0.05. Careful not to type in 0.5 or something wrong here. And then my T for this one, I'm going to use 6. So I'm going to check for 6 years. Now keep in mind, I already have the answer. I'm just showing a different method. So I should get 1,200, right? So when I go back to I, you're going to press alpha, enter. All right, and so I get 1,200. Now here's why this is neat. When I go and set up for 8 years, the only thing that's going to change is my 8. So work out the same problem, but change the 6 to an 8. And so I'll go here, and some people clear it and they find that they can't move from there. So if you do clear it, you have to leave something in there, and then you're able to move back down. So I can change that 6 to an 8. And when I move back up, alpha, notice now with 8 years, I'm getting charged 1,600. So notice 6 years charge 1,200, 8 years charge 1,600. What should happen if I take even longer to pay that off? Well, I'll go back and I'll change that 8 to a 10 now. And how much interest would I be charged? Alpha, enter, and now it would charge me 2,000. So here's the setup that I used, and in this case I get 2,000. Now here's what I want to focus on. This is one answer. This solved for I, and I means interest. So if I take 6 years to pay something, I pay 1,200 in interest. 8 years I pay 1,600 in interest, and 10 years I pay 2,000 in interest. My concern is this. Why would I put the A? Well, I told you that A means the total. If you borrow 4,000 and you pay 1,200 in interest, what's the total that you actually repay? What you borrowed plus what you pay to borrow, my total would actually be this number. I want to focus on those two styles of answers. For every problem I do, there's going to be an interest and a total. Okay, so for right now, notice there's an interest and a total, and over time, if you take longer, you will have to pay more. Okay, so let's compare this to a compounded example. All right, so I got the same exact information, but this time I'm changing it to compounded. So I'll work this out kind of quick. It's the same idea, except now my formula has changed. As far as PRT, same information, 4,000, 5%, do the por cien, and then I'll do T for 6 years, then 8 years, and 10 years. There are some differences I want you to notice. Now, let's set up the formula. A equals P, parentheses 1 plus R, to the power of, and I'll do 6 years first. So I can do the same thing on the calculator here, but notice this formula, that's not the same one I'm going to use. I want to use compounded now. So I'll go back and I'll clear this out. And I'm going to start off with alpha A. Make it bigger so I can see my keys. So alpha A and then alpha P, parentheses 1 plus alpha R to the power of alpha T. Now, since I didn't reset, I have my same numbers there. Otherwise, if it was a different example, I would want to double check that the P is the same, the R, and then I'm going to do 6 first. So let's change that 10 to a 6. And how much do I get? So what is my A equals? So according to my calculator, I would solve, and it gives me this answer. Now, here's what I want to try to see if you guys catch. This answer is way different than my previous answer, but it's the same information. I got I equals 1,200, but over here, I'm seeing something else. So what I want to be able to do is compare. See, this answer gave me A, the total, and I want you to compare the I. All right, so what I'm going to do is, to find the interest, I take away the amount I borrowed, and whatever's left must be how much I was charged in interest. So I want to focus on these two answers. You have an A answer and you have an I answer, but notice this time, instead of adding, I had to take away the 4,000. So I want to work out these problems this way now. So I'll go check the next one, and instead of 6 years, I'm going to check with 8 years. And when I go solve it, what's the total amount for 8 years? Well, this time I actually get 5,909 with 82 cents. So since this is a money problem, you'll want to go just 2 places after the decimal. So notice the difference between these examples and the previous ones. It looks like compounded interest is more expensive than your simple interest. So I'll take away the money that I borrowed, and how much was I charged in interest? So what's that, 5909? I can go back to my home screen to do this. Ooh, this got small. Alright, so hopefully y'all can see that. So what's 5909.82 minus what I put in, the 4,000, or what I borrowed, the 4,000. And so I would have 1909.82. Okay, and then finally the last one. Let's go ahead and set up that last one. I'm going to do the same example, except in place of t, I'll try it for 10 years. And notice over time, it looks like for 6 years, looks like for 8 years, I'm starting to get charged more in interest. So the idea is, do you want to take a long time to pay off debt? And the answer should be no. So let's go ahead and set this one up. I'll go back to my math solver. You know what, let's try it this way. I haven't done a few of these. So let's type it in just here at the home screen. So what's 4,000 parentheses 1 plus 0.05 to the power of 10. And in this case, I would get 6,515 with 58 cents. And if I want the interest from this, I would have to do what to that answer? Take away what I borrowed. So what's that answer minus my 4,000? And this is how much interest you have. So every answer that I have here, we're going to be going with 2 versions. So I got A, the total, and I got I, the interest. Notice though, on this examples, I had to subtract to find the interest. But on the simple interest, I had to be adding them to find the total. So depending on what you're trying to do, you need to be careful with I and A. But they both have an I and an A to solve. Now, here's the main reason why I cover both. Let's pretend it's something like this. Compare 34,000 at 4% for 5 years at simple and compounded interest. Now, how does it affect? So the first thing I want to do is, well, I want to use these formulas, right? So figure out P, R, and T, and then here are my numbers. Again, careful with the por ciento. And as far as the first one goes, I'll simply just set up I equals P, R, and T. And I'll go work that out. Now you can do it on Solver. Get more space here. Okay, you can do it on Solver, but I'll just do it here at the home screen. So what's 34, 100 times 0.04 times 5 years. Now the numbers that I chose, by the way, I'm hoping it's what you would think for a car. A car could easily cost about 34,100. 4% would be a normal interest rate somebody might pay, and typically people take about 5 years to pay off a car. Okay, so when I work this out, I end up with 6,820. Now compare this answer to my compounded answer. So it's the same idea, same P, 34,100, same R, same T, but it's a different formula. So I'll go do this one over here on Solver, since I already have it set up there. So Math, Solver, and I have the right formula, so I'll just go ahead and change the information. So this time, what's my P? 34,100. My R is 0.04, so I'll just change this to 0.04. And then my T is going to be 5. So this way, I end up with this big answer. 41,487 with 86 cents. I'm trying to compare these two problems. The issue is, can you compare I to A? They're not the same meaning. This one's telling me how much interest I'm being charged. This one's telling me the total amount. When you want to compare two formulas, you got to compare the same thing to the same thing. So if I look at my simple one, what's my A? How do I find the total? Well, from here, I would have to add what I borrowed. So the total here is this much now. So can I compare A to A now? So my question could be, if you were going to choose, which kind of financing would you rather have? Would you rather pay compounded and pay 41,000? Or would you rather have simple and pay 40,000? So if you're the one that's borrowing, you'd want to pay less money back, so you'd want this one here. But what if this is investing? If you want to invest money, you want to earn more, then you would go with compounded. So I can compare A to A, but I can't compare A to I. The same way would work on this one. If I want to find my interest, I would take away what I actually borrowed, and that amount that's left, now I can compare. So it's important you guys understand how to get both of these. I want to be able to compare the right thing to the right thing. Now, we got simple, we got compounded, we got the comparison. Here are some of the other types of examples I want y'all to see, and that way you guys know why I use this version so much. I'm going to reset my calculator. I'll pretend I'm starting from scratch on the calculator. That way I don't have anything on Math Solver. So I'll go to Math as soon as it lets me. Alright, so Math Solver. Alright, so let's try something like this. And hopefully you can tell what's different about this one than all the other examples I've done. It's a little bit more wordy, but it asks how much time would it take to invest 5,000 at 12% simple interest to become 15,800. So my big thing here is I'm asking for time. In every other example, I always gave you the time. I always told you how many years. Now I'm asking how many years it would take. So for this approach, I'm going to start off the same way, and because of the keyword simple interest, I know it's this formula. Now notice this time what I'm going to do when I go figure out the pieces. I'm going to include I. The reason I have to include the I is because I don't know the T. But I should know the rest. So the easy ones that you should know is what's P, my starting money? 5,000. And then what's R, my interest rate? Well, it's 12%. And that would give me 0.12. Now, here's where you want to be careful. What's your I? Remember, I is the interest. In the problem, I told you that 5,000 at 12% simple interest to become 15,800. I want to have 15,800. That's my A. Can I put A in place of I? Can I put the total in place of a spot where I only need the interest? So how do I find the interest from here? Take away what you put in. The rest, my 10,800, is my interest. Now I can work with this to solve. And the best place to do this is going to be over here. So I'm at Solver, and I'm going to go ahead and set up my equation. I equals PRT. So let's do alpha I, alpha, where's P? P, alpha R, alpha T. Now, it's all set up for me. So exactly what I'm going to put in here is exactly what I've already set up. So my I is 10,800. It's a very neat, clean way to solve these types of problems. Your P is 5,000. And your R is, I can type it in as 12%. And what's neat is that it'll already write it for me in the decimal. So that's always nice. You could also just have typed in the 0.12. And then t, well, I don't know t. So what am I gonna have to press here to figure out my t? Alpha, enter. It would take 18 years. That's how you would set up this type of example. And it makes perfect sense here that I would use solver to solve for t. Okay. Now if you had answer choices, it would also work to use substitution, but since these are just free notes, there is no answer choices here. Okay. So when you're asking to solve for something else, that's exactly when you want to use solver. Okay, so let's try a slightly different example, but this time notice my keyword is going to be compound interest. So starts the same way. How much time would it take to invest $7,500 at 7.5% compounded interest to become this amount? I start with the formula and I go and figure out all the pieces, but because I'm missing t, notice what I have to include. I'm starting off with the a. Okay, so the easy ones to figure out should be the 7,500 and the rate, which becomes 0.0725. Now, what's my a? So notice when I said it, I put all of this to become 13,376. That already is my a. There will be no adjusting this number. I wanted the total. It gave me the total. I can use it just like that. On the previous example, they gave me the total, but I needed the interest, so I had to make an adjustment. No adjustment needed on this one. So let's get this set up. So I get all my work here. Let's set it up. So I'll use this formula here to solve for t, and the easiest place will be to do it on solver. Okay, so let me put them side by side. So all of this stuff here, it's not going to work. So I guess I'll just reset to make it easier on myself. Alright, so I'll go back into Math Solver, and this time I want to set up my compound formula. So Math Solver, and now I'm going to start off with alpha A, and then alpha P, parentheses 1 plus alpha R to the power of alpha T. Okay, so I got that typed in there, and I'm just going to sub. So I know my A, so I'll put that in there. 13,376.09. My principal, my starting amount was 7,500, and my rate would be 0.075. Notice that it automatically puts a decimal in the front. That's fine. There's no issue with that. And so what is t? So since I'm using it on solver, I just got to solve for t. And this one would take a little bit of round off error, but the answer is basically just 8. It would take 8 years for me to turn 7,500 into 13,376. Okay, so this is the exact reasons why we want to use solver instead of just the home screen, because I'm not always going to ask you to solve for I or A. I could ask you to solve for T like I did in these examples. Okay, I want to do just one more set of examples, and then that's it. Hopefully this covers all the different types of scenarios that you guys might come across. Alright, so let's notice the change here. Now I'm asking, at what rate would it take to invest $25,000 for 7 years compounded annually to become $47,948 with 13 cents. Now notice, now I'm asking for R. So it does change the way that I have to set it up. So we'll start with that keyword compounded, and that'll make me start off with the formula. Okay, so I got my compounded formula. And because I don't know R, notice I'm gonna have to go and figure out my A, but I'll come back to that A in just a bit. So with what I know right now, what's my starting money for P? It's gonna be 25,000, okay? And notice what I already put for A. So because I didn't know R, I have to do A. That means total amount. And notice I want it to become this much. I want it to have a total of that much. So I'll use A is there. My starting amount is 25,000. My rate, I do not know, but I do know T. It'll take 7 years. So solve for T. So I want this equation set up on solver. So let's go ahead and set that up. And we'll go ahead and take a look here. All right, so I already have the right formula, so let me just go ahead and zero everything out, and I can start it off again. All right, so what do I want A to be? So notice I have the right formula, and then what do I want my A? What's my total amount? 47,948.13. All right, for my principal, it was 25,000. I don't know my rate, so I'll just leave it at 0. And then what is my T time? 7. So now that I have everything set up, go and solve for R. So what is my rate in this case? So alpha, enter. Okay, so this is the answer that I get. Now, I use solver. Here's the setup that I did. So if my answer is 0.097, and I'll use a 5, so I'll round that off. I want you to be careful about something. Every time I get my answer R, it's giving it to me as a decimal, and typically you're presented with your rate as a percent. So how do you change your decimal back to a percent? Well, the quick way is, normally when I give you a rate, you're divided by 100. Well, I need you to undo that. So what's the opposite of dividing by 100? So you would do times 100. So while my answer is 0.0975, I might show it like this, times 100, so that I can put the percent symbol at the end of it. Now they're both correct, I just don't know which one they might give you. I suspect that they will probably give you the answer choices as a percent rather than as a decimal. Okay, so right here at the very end, notice why I did times 100. I did the opposite of dividing by 100 so that I can get to my percent form. All right, now let's go ahead and do one final one. So now I'm asking, how much would have to be invested to end up with 1 million after 35 years at 12% compounded interest? So the $1 million question, okay? There's lots of different ways to become a millionaire. You could do it monthly, yearly, how much you want to put away. But for this scenario, it's if you put in a certain amount right now, how much from right now to 35 years later would you have to get a million? Okay, so my keyword is again compounded. So I'll start with the formula. And I want to go ahead and, well, I need to think here. I want to find out how much would have to be invested. What does that mean as far as A, P, R, T? Which one am I looking for? Okay, well, I know this one. I know the amount that I want to have. Let's see, I have 35 years at 12%. So I know the T and I know the rate. So what I'm actually looking for here is the P. How much would have to be invested? How much do I have to start with? So let's go ahead and figure that out. I got all this set up here. Let's go ahead and put this on solver to figure out what P is. What is my starting amount of money? So let's go ahead and take this to math solver. And notice the formula is going to be the same formula. A equals P parentheses 1 plus R, to the power of T. And I'll go ahead and zero all of this out since I have new information now. All right, so then let's see. I know my T, so I'll replace the T with the 35. Okay. I know my R is 0.12. Let's see, for my P, I don't know it, so I'll leave it alone. And my A is 1 million. I think I did that right. Yeah, 6 years. All right, so solve for P. So what's the starting amount of money for at 12% for 35 years so that I can get to $1 million? And this answer, I'm kind of curious myself about this. Oh, look at that. It's lower than I thought. So you would only need 18,939, and 35 years later, that would become $1 million. That seems almost unbelievable, right? But that's the power of compounded interest. This is when your money makes money for you. So here's my setup. I use solver here to get P, and in this case, my P, my starting amount, would be 18,939 with 53 cents. Okay, so this is how you use simple and compound interest. So notice that the longer you take, the more interest that you make. So 35 years is a really long time, but for 18,000 to become $1 million, that's because of that long time. Okay, so hopefully you guys have a good understanding of how to use simple and compound and some of the other ways they may show you these problems.